Namaste, I JV'n Swarnima, Assistant Professor in Jayoti Vidyapeeth Women's University, Faculty of Education and Methodology, Department of Science and Technology. In this session, we will discuss about the support reactions. So there are so many supports which have different reactions. So let's start. When a number of forces acting on a body. So what is the mean of when a number of forces acting on a body? Let's suppose this is my body and there are so many number of forces. Then what will happen if this body is not supported? If this body is not supported, it will fall down because of this forces. It will fall down, it will deform, it will deform means it will cracked, it will cracked, or it will destroyed completely. Okay, so it will deformed. So let's suppose, let's take an example for this support reactions, support system, to understand the support system. So if I have a if I have a structure, in the structure I have a room. Okay, so in a room I want to tuck a rod for hanging my clothes, or for hanging my any curtains or something like that. Okay, so what I have to do, I have to do first thing, firstly, without support, we are talking about without supports. Then I take this rod, I have to tuck in between these walls. My hands are walls of a room. So I just simply tuck it, didn't provide any support, didn't provide any support first, didn't fixed it to this wall. So there is no support with this rod to this wall. Okay, so I just simply tuck it. Now what I have, now secondly, what will I do? I applied the force on this body. This is my body. This is my body, which I take as rod. Okay, so I applied forces like some hangers of clothes, some curtain, or something like that. So I just applied that body, that structure which I take, sorry, that body which I take, like hangers or like curtain, I take it as a forces. Okay, so when I applied forces on this body, it will fall down because of that forces. Why? Like I applied this on this rod to any force, then my this rod will comes down slowly, but in the end it will fall down because of heavy loads, because of this rod is not supported, and this rod has lack of support system. So it is necessary to provide supports in a structure to a body with other body, so my forces will not deform this body, and my forces will, if my forces will not deform this body, my body remains undeformed. I can use it further. That's why in when we using curtains rod, there is also a support system which tuck like this, and then we applied the curtain on this rod. This this system and this support which we gave to this rod is fixed with the wall. So this is my support to that curtain rod, for that curtain rod. So that's why we need to provide the supports. If a body, if a number of force acting on a body, and the body is supported to the another body, which is my wall. This is my body, first body, which is my rod. This is my wall, which is my second another body. Okay, so if I give support this and the number of forces acting on this body, then second body exert a force known as reaction. This second body is exert forces which is known as reaction. Which reaction is the reaction of these forces which create the equilibrium condition for this rod to make it undeformed. Okay, so support, the second body is known as support firstly, and the force exerted by the second body on the first body is known as support reaction. the second body, which is my wall, and the force exerted by this body is my support reactions. Okay, this is my support, and this is my support reaction, which gives to this structure, which gives to this structure, so my structure will not deform by because of the forces on this structures. Okay, so there are so many types of supports, like simple support, which we said, also knife edge supports, roller supports, pin joint support, smooth surface support, fixed or built-in support. So firstly, simple support, it's a simple support, like this is my body and my simple forces, sorry, simple supports are acting on this body like this. Okay, as we saw in a diagram A and B. This A diagram shows a typical version of my supports, which find also what how can my supports it react in on this body. This is my B structure is my free body diagram, which we draw after we have this body. We simplified it into this form, which is we known as free body diagram. Okay, so this is my simple support. In this simple support, A, the react this point A and B are my knife edge supported, will be normal to this beam. Okay, what is beam? In the structure, in a structure, that means in a suppose in a house, in a home, in a any building, in any this kind of structure, there is a beam in our room. Okay, so that is my beam, and for supporting this beam we have columns. Wherever the columns, there is also a beam. So my beam is support on this column, so the column is, we can say the column is like support for this beam. Okay, so simple supportive beam is simply like this, which we further draw like in the free body diagram, which is RA and RB. Now, what is roller support? Roller support is on like in this diagram, these are my roller supports. In the roller supports there is only one reactions, okay, which is only vertical reaction. Why vertical reaction? Because this roller supports acting like this, and we have what, we have rollers, so we can the supporting reactions is my only in vertical direction. Okay, so again we draw it like a free body diagram, which is RA and RB, and this is my beam. The next is pin joint. In this pin joint there is only a joint which we set as a pin joint. This is my support reaction, which in this pin joint we also say it as a hinged joint. Okay, so the reaction at hinge and may be either vertically or either inclined. It may be vertical or it may be inclined on a some angle. So depending upon the type of loading, how what kind of loading in this support reaction are applied, the pin joint is depend on that. So if the load is vertical, then the reaction will also be vertical. But if the load is inclined, then reaction at hinge and will be also inclined. In the supports, smooth support surface support, there is a smooth surface which we gave a support. This is my bodies, then this is known as smooth surface support reaction. The reaction will always act normally to the support as shown in this figure. Okay, next is our fixed or built-in support. That means ki support at A. This A point is known as fixed support. In this case, a fixed support, the reaction will be inclined. Also, fixed support will provide a couple. So let's understand this all with the normal phenomena. Like if I said the fixed support, normal example, sorry, if I said the fixed support, that means I fixed my I fixed my this rod to this wall like this. Okay, so my one end is fixed on this wall and my other end is free to move. Here there are three types of reactions, which is horizontal, which is vertical, and which is one more reaction, which is couple or movement. Okay, what is couple or movement? Which gives this body, which allow this body to move like this. Okay, in a round circle or something like that path, this body can move if the movement is applicable on this body. Okay, so my fixed support, what my fixed support do? My fixed support is not allowed to this body to move like horizontal, like vertical direction, not in horizontal direction, or not in couple or movement direction. So okay, so this my wall, this structure is fixed with this body, and my body will not move, whether it will not move until the deformation level is not come. Deformation level, that means if my force on this point is my fix, this point is not heavier, which this rod is not take as, so my body will deform at that point. Okay, in the pin joint, my body in the pin joint, this is my pin joint. I just pinned i just pinned it like this. I just pinned it. Okay, but in this pin joint my body can move like this. It can move like this. Okay, but it cannot move like in horizontal direction, it cannot move like in vertical direction. So there are two reactions. First one is horizontal. There are two support reaction, which first one is horizontal, second one is are vertical, because this body cannot move in vertical direction because it's pinned here, and cannot move in horizontal direction. It can move in this direction in couple or in movement. If the couple or movement is applied in this body, it can move like this. Okay, in a roller support, there the force is fixed. The in the roller support, the my body is fixed like this, and it cannot move like this, but it can move like this. Sorry, it can move like this, but it cannot move like this. So that's why in this body my support reaction is only one, which is vertical support, because this kind of reaction is not provided by this support. In this support, roller support, my body can move like this because of roller support, but it cannot move like in vertical direction, and it cannot also move like in by couple in this direction. So that's why uh, there is only one reaction, which is known as, which is our vertical reaction. So these are my roller support, pin joint support, and fixed support. Now, types of loading. How many types of loading? There are three types of loading: concentrated or point loading, which we simply said, if then this is my a body, and this is my point support. Only this point I have loading. Sorry, this is my body and this is my point load, which in this point, on this particular point, I have load. On these point and these all structure, I don't have any load. Only this point I have load. So that means my point load. This is my known as point load. Uniformly distributed load, that means if I have this body and I have this load, then in first we have this point load. My all load are only or at this point. If I talk about the uniformly distributed load, which we also say UDL, then my this loading are parallelly equally giving the all my loads on this support on this body. So sorry, on this body. So all the points are carrying equal and uniform loading, which is given to this body by this load system. Okay, Uniformly varying load, uniformly varying load is like this point is less than less load than greater and then greater. That means my graph of loading is like increasing to the next end of the body. So this is my uniformly varying load. Let's more talk about this. Like, firstly, concentrated or point load. This figure shows a beam which is A and B, which is simply supported at ends A and B. Simply supported, there is no roller support, there is no fixed support, there is no hinge support. There is simple support only. Okay, so there is simple support at A and B. The load W acting at point C. This load is known as point load or concentrated load. Hence, any load acting at a point on beam is known as point load. Uh, it is not necessary that there is only one point load acting on a beam. There is so many point load there. There can be acting so many point load on a beam, but the point load means only this point I have this W load, only this point D. If I have the point D, then W2 load is acting on this point D. That is not varying. This W load is not varying to the throughout this beam. This is only acting on this point C. If this W point is, if this W load is more than my beam can allow, my beam can permit the load system, then my beam will deform because of this load. And where it will deform, it will deform at this only C point. It will not deform at A point, it will not deform at B point, it will only deform at C points. Okay, so this is my concentrated point load. uh, like this, there are so many points load. There are so many points loads in the beam, which we can take as a questions or queries or some kind of that. So let's start the question first. Problem first. A simply supported beam AB spans 6 meter, carries a point load, carries point load 3 kilonewton, 6 newton at distance 2 meter and 4 meter from left and A, shown as figure 5.12. Find the reaction at A and B analytically and graphically. So graphical method is not in our course. So let's only talk about the analytical method. So we have this reactions. Okay, first beam point is A and point is A, second point is B. We have 3 kilonewton and 6 kilonewton are loads, which is 2 meter away from this A point and 4 meter away from this point. So by 2 meter there is 3 kilonewton and by 4 meter there is 6 kilonewton. Then what we have to do, we have to find out this reaction. It is Ra and this Rb. Now it is clearly understandable, or it is more important that we have to fix our reactions by positive and by negative signs. How it will it how we can fixed it. We can say that whatever my force is applying like this in clockwise direction, whatever my force is applying by another to another body in a clockwise direction, we will take it as positive. If it will in anti-clockwise direction, we will take it as negative sign. Okay, so let's start. There is basically three reactions. First reaction is sigma a sigma Ra equals to, sigma h equals to 0, sigma v equals to 0, and sigma m equals to 0. There are three reactions. What is sigma v, what is sigma h, and what is sigma m? Sigma h is all my horizontal reactions are all my horizontal reaction sums are equal to 0. Okay, that is my first equilibrium equation. Second equilibrium equation is all my vertical forces sums are equal to 0. That is my second equation of equilibrium. Third equation is all my moments sums are equal to 0. That is my third equation of equilibrium condition. So if these three conditions are applied on a body, then my body is in an equilibrium condition. So we have to take it as principle in this question, in this type of question, where we have to find out the reaction. So like, let's start. First we take sigma h equals to 0. Is there any horizontal reaction? No. Then it will also 0 equals to 0, total. End of the story. There is no horizontal reaction, then there is no need to sum, there is no need to consider it in this question. Second, sigma v equals to 0. Sigma v equals to 0, that means ra plus rb equals to 3 plus 6. Why I take it as ra plus rb equals to 3 plus 6? Why I didn't take it in the same side? Because this RA and RB are in upward direction, and this 3 plus 6 are in downward direction. If I take it in the left hand side, all the body, or all the magnitudes in the left hand side, like I said, sigma v equals to 0. So sigma, if I take it, then ra plus rb minus 3 and minus 6. Why this minus? Just and just because of the opposite reaction from ra and rb. That's why I take it as minus 3 and minus 6. Done. So ra plus rb minus 3 plus minus 6 equals to 0. Then what will be my reaction? Ra plus Rb minus 9 equals to 0. I took my minus 9 to the another side, then my Ra plus Rb equals to plus 9, because my negative sign will be positive if I take the any structure, any magnitude, or any point to the another side of equal to. Then my Ra plus Rb equals to 9. That is my first reaction. Okay. Now, third reaction, what says? Sigma m equals to 0. Then what is the reaction will be? Sigma m. What is sigma m? Sigma m is movement. So how we can calculate this movement? We can calculate it by multiplying the distance of the load. Okay, so let's take ma equals to 0. Let's take ma equals to 0. Let's wait a minute. Okay, let's take at sigma m. I'm sorry, because I didn't take this sign of sigma at right now, so I write in this form, like sigma m is 0. Okay, so sigma m, in this sigma m I take at a point. Okay, at a point. Then first r a multiply by 0. Why this 0? Because this force having no distance, because we are taking all the moment at this point, at a point, and the ra is also acting on a point, then there is no distance, so that's why we are taking ra multiply by 0. Then plus 3 multiply by 2. Why this 2? Okay, 3, this 3 and this 2, because the distance from this point of a of this force 3 is 2. So what I said, moment is multiplying distance and the magnitude of force. Okay, so that is my moment. So 3 multiplied by 2. Now At the starting of this question, I said we have to fix the directions of a structure of for solving these kind of questions or for these kind of problems. And we have to fix because in the next question or in the other question we not didn't we will not confused by the direction, so we have to fix it here. So what I said anything goes in the clockwise direction, take it as positive. But if anything goes in anti-clockwise direction, take it as negative. Okay. So for this point, my value is positive. For this structure, for this structure, my value is goes like this. So that is my positive. Okay. Sorry for the this. Okay, I take it again. Ra multiply by 0 plus 3 multiply by 2. Okay, why this positive? Because the direction of this 3 to this a is positive. So I take it, so is in clockwise direction, so I take it as positive 3 multiply by 2, but with the positive sign. Next is my 6. Okay, multiply by the distance between this point to this force is 4. Then 4 magnitude is 6. And also direction is always clockwise, is already clockwise, that's why my sign will be positive. Now talk about this RB. Talk about this RB. RB multiplied by the distance, this reactions RB is multiplied by 6 because of the magnitude of this support is RB, because we don't know the value magnitude of RB right now, so I take it as RB. Okay, and the distance between this point to this point, this support is 6 meters, so I take it as RB multiplied by 6. Now the point is sign, it will positive or it will negative. How we can say? We can say by the directions. Okay, so take it as this B is moving like this, moving around by this point is like this by in anti-clockwise direction. So my sign will be negative, and this equation will be equal to 0. Okay, so Ra multiplied by 0 is 0, plus 3 multiplied by 2 is 6, plus 6 multiplied by 4 is 24, plus Rb multiplied by 6, which is, sorry, R minus Rb multiplied by 6 equals to 0. Next, take this minus sign to this to another side, then my value will be 6 plus 24 will be 30. Okay, equals to RB multiplied by 6. To find the value of RB, we will divide this 6 to 30, divide by 6. Now then my value will be 5 kilonewton. Done. So my RB value will be 5 kilonewton. Then what I have to do is I have to put this 5 kilonewton in the first equation, which I have RA plus RB equals to 9. Then put the value of RB 5 kilonewton in this equation. Then my value will be Ra plus 5 plus equals to 9. Then Ra equals to 9 minus 5, which will be 4 kilonewton. The value of Ra is my 4 kilonewton. So this is my simplest method to find out the reaction, support reaction to these three equilibrium equation. I hope you don't have any query in this session, in this problem. Let's take another question. Another question says, a simply supported beam AB of length 9 meter carries a uniformly distributed load of 10 kilonewton per meter for a distance of 6 meter from the left end. Calculate the reaction A and B. Now, what is this? This is uniformly distributed load. This is not the point load. How it look like? It look like this. Okay, all my 10 kilonewton load is applying on this 6 meter length all over my 10 kilonewton, equally applied at this 6 meter length. So this is my UDL, uniformly distributed load. So the length of beam I have is 9 meter. The rate intensity of this load is 10 kilonewton per meter. Length of UDL, yeah, that means in UDL is applied on 6 meter length. Then my total load due to UDL is length of UDL multiplied by rate of UDL. So why we are doing this total load of due to UDL? We are making this UDL to, we are converting this UDL to a point load. How it will convert? We simply multiplied my UDL length to my intensity of the UDL. So it will make my point load, and the where it lies on the half of the length of the UDL, applied UDL. Okay, so what is mean? That means if I have the length is 6 meter and my intensity is 10 kilonewton per meter of this UDL, then if I want to convert it into point load, then I multiplied this 10 to this 6, then my value is 60 kilonewton, which is my value for point load. Okay, now where it can where this point load is applied on this structure, it will apply at the half of the length of the UDL, sorry, half of the UDL length. That means on the midpoint of this length. So if my value of this length is 6 meter, then my value of where my point load is applied is 6 by 2, which is 3 meter from A. This, from this A point, my 3 meter away my point load will be applied. Okay, and the intensity of point load is 60 newton kilonewton. Okay, now what is the next process? The next process is the same as we done in the problem 1, where we have to consider the three reactions, equilibrium reaction. First is sigma h, second is sigma v, third is sigma. Sigma h says all the horizontal the all the sum of all the horizontal reaction is 0, equal to 0. Second is sigma v equals to 0, that means key sum of all vertical reaction is equals to 0. Third is moment sigma m equals to 0, that means key all sum of all moments of sum of all moments are equals to 0. Let's take first equation, which is sigma h equals to 0. Then is there any horizontal reaction? No, there is no horizontal reaction. Then my sigma h equals to 0, that means is already automatically will be 0. Next reaction is sigma v equals to 0. Then sigma in for sigma v, I have this Ra, I have this Rb, and I have this point load, which is 60 kilonewton. So Ra plus Rb, because of these both forces are in upward direction, and minus 60 because this 60, this point load which I using which I convert it like this. Okay, so this is my 60 kilonewton load. Okay, this is my 60 kilonewton load which is applying at this point, which is 3 meter. Okay, which is 3 meter. Now what I have to do? Okay, so first equation will be Ra plus Rb equals to 60 kilo Newton. Why this equals to 60 kilonewton? Because this 60 kilonewton having the downward direction and RA and RB having the upward direction. Both directions are opposite. So minus 60 will take negative sign and RA and RB will take positive sign. So if I take the negative sign from the another to another side, then my negative sign will be in positive sign, converted in positive sign. So Ra plus Rb equals to 60 kilonewton. This is my first reaction. Okay, next what we will do this sigma m is equals to 0. Then sigma m equals to 0, that means my all sum of all moments will be equals to 0. So let's take at a point, let's take it as, let's take from a point. Okay, from a point r a multiply by 0. Why 0? There is no distance in between this a to this support reaction. Okay, supports. So ra will be 0. Then I have this 60. I have the distance from this A point is 3 meter, which we calculate like this, which we say is that half of this UDL length will be my distance from this point is of this point load. So 60 multiplied by 3, what will be the sign? My sign will be positive. Why? Because it moves around A in the clockwise direction. So my RA plus 60 multiplied by 3. Next, I have this RB, which is in negative sign. Because of this RB is moving around this A point in anti-clockwise direction. So RB multiply by distance of from A to RB is 9 meter. So RB multiplied by 9 equals to 0. Then RA multiplied by 0 is 0 plus 60 multiplied by 3, that which is 180, negative sign RB multiplied by 9 equals to 0. Then I take this RB section to the another side, then RB multiplied by 9 equals to 180. Then for find out in RB value, put this 9 in the downward of 180, then 180 divided by this 9, then my value of RB will be 20 kilonewton. Done. Put this RB value in this equation. Then RA plus RB value is 20 is equals to 60. Then RA is equals to 60 minus this 20. Then RA value will be 40 kilonewton. So this is my whole solution of this kind of for this kind of problem, which we have a UDL or uniformly distributed load. I hope you don't have any query in this session, but if you have, then please mention in a comment box. We will do the more same kind of problems and some another points of this support reaction in the next session. Thank you very much for listening this video.